Hi everybody. I just thought I will give you a little introduction to waves, and because when I had that session with you, somebody asked me what a pulse is. So here's just an animation of a pulse. A pulse is a single disturbance that can be sent down a medium. So this is an example of a pulse. So it's like when you jiggle a string or a spring, the disturbance goes down the medium. So that's a pulse. Now, a wave is when you keep moving your hand up and down, holding a string, then what you produce is a wave. And we actually have slinkies in the classroom, in the lab, but unfortunately now we don't have all those resources. So a wave is a succession of pulses. Okay, and what do waves do? They actually transmit energy from one end of the medium to the other. So in this particular example, your hand must have been there and you jiggled the string and the energy went from this end to the other end. And when it stopped, you found that all these particles that make up the medium, that is the rope or the sling, still stay where they are. The only thing that happened was each particle just moved up and down. That's what happened. Okay. So in a wave transmits energy from one end of a medium to the other without the actual movement of the material medium. That means the particles here don't come over there. They just stay where they are. The only thing they do is go up and down. Okay, so that's the thing about the wave. Now, what happens if you send a pulse down a string and then it comes to the end? When it comes to the end, if the end is tied to something like we call a fixed end, it's going to get reflected. So the next one shows a pulse going down a string, but it comes to the end and it shows you what happens when it gets reflected. Now, the incident pulse, the pulse that's coming, is actually in the form of a crest. But when it hits the end, which is a fixed end, what goes back is a trough. Now, when a crest gets reflected as a trough, we say that there is a change in phase. So that's what happens. So it's come to the fixed end and then it goes back. Okay, however, because the medium itself hasn't changed, the speed of the wave doesn't change, so it stays the same. The frequency stays the same, the amplitude stays the same. So the wave speed, frequency, and the wavelength as well, they all stay the same. Okay, so that's what happens. There's also one which I don't have an animation for, is when a pulse gets reflected at a loose end or a free end. So if it wasn't tied, but the string was just there loose. So it comes to the end and it does get reflected, it goes back, but what comes as a crest will go back as a crest. And I'll try and do some diagrams and post it for you. Okay. Now the next one is if you tie two strings together of different thicknesses, or one is tight and one is loose, it actually amounts to two different medium. So when you have a pulse going from one medium to the other, then it amounts to refraction, or we call this transmission of pulses. So here's one pulse going from one to the other. The second medium is a slower one. Can you see it's still moving in the second one? So what stays the same is the frequency, but because v equals f lambda, of the wave speed is frequency times wavelength, frequency stays the same. If it goes slower, that means if the speed reduces, then the wavelength reduces. So how do you show the wavelength is smaller? That this gap is smaller compared to that gap. This one, because it gets reflected in the same medium, there's no change in speed, no change in wavelength, but we call this a hard boundary because that's a slower medium. So what comes as a crest goes back as a trough. This medium, because it goes slower, then you have the reduced wavelength, but for transmission there is no phase change, so it still is a crest. So that's to do with wave reflection and wave transmission for one-dimensional pulses. Now, what we're going to be doing next week is what happens when it's like waves on water. So that's called two-dimensional pulses. And I might just make a little video of that explaining to you, and let me know if this was useful. So bye for now.